Factoring and GCF. So factoring is finding two or more factors of a number or a polynomial. So the greatest common factor of two or more monomials is the common factor having the greatest numerical factor and with variables having the least degree. So thus the term ax raised to n is the GCF of a polynomial if, so number 1, a is the greatest integer that divides each of the coefficients of the polynomial. Number 2, n is the smallest exponent of x in all terms of the polynomial. So let's have some example. Okay, so for example, I have here 6a and 18ab. So how are we going to find the greatest common factor of each pair of monomials? Okay, first thing we need to do is we're going to write the factors of 6a and 18ab. So factors 6a, you have 2 multiplied by 3 multiplied by a. Also 18ab has a factor of 2 multiplied by 3 multiplied by 3 multiplied by a multiplied by b. Okay, so the GCF of 6a and 18ab is, number 1, a is the greatest integer. So what is the greatest integer that divides each of the coefficients of the polynomial? Meaning, what is the integer that divides both 6 and 18? So in this case, you have 2 multiplied by 3, that is 6, and also 2 multiplied by 3, that is 6. And n is the smallest exponent of x in all terms of the polynomial. So what is the smallest exponent? In this case, that is a. So the GCF is 6a. So let's have another example. So another example is 10a, so have 10a and 12a squared b. So again, we will do the same procedures. So let's have the factors of both 10a and 12a squared b. So the factors of 10a is definitely 2 multiplied by 5 multiplied by a. At the same time, 12a squared b has a factor of 2 squared multiplied by 3 multiplied by a squared multiplied by b. So again, what is the GCF? So the GCF is what? A is the greatest integer, again, greatest integer that divides each of the coefficients of the polynomial. So in this case, you have here 2 times 5, that is 10. 2 raised to 2, that is 4 times 3, that is 12. What is the greatest integer that will divide 10 and 12? Could it be 5? Don't think so. Could it be 6? Nope. How about 4? Nope. So the answer is greatest GCF of 10 and 12 is 2, because that is the greatest integer that divides 10 and 12. So how about for the variables, or for n? So n is the smallest exponent of x, smallest exponent. So here we have, that is a squared, b. So smallest is a. So the GCF of 10a and 12a squared b is simply 2a. Okay. So for the next, I want you to answer it on your own. And then we're going to process it afterwards. So what would be the GCF of negative 8x squared y and 16xy? So you have to try this. Okay, I'm going to give you 5 minutes only to do this. You can actually pause this video and have some clock or alarm or whatsoever cell phone that you can use to time, or have a timer, so that you can answer this on 5 minutes. So okay, so let's proceed. So this time, we're going to deal with factoring. Okay, so the task is, let's factor the following completely. So for the first example, we have 3x plus 6. Okay, so how we're going to factor this 3x plus 6 completely? So, well, I guess this would be an easy problem. So just look for the common factor of both 3x and 6. So if we're going to use the long method, so that would become, get the factors of 3x and 6, and that would be 3 and then x and then 3 times 2. So you can see our GCF here is 3 and 3 only. Okay, because we have here x raised to 0, and x raised to 0 is the smallest exponent. Okay, so then let's bring out 3, factor of 3, and that would be x plus 2. Okay, so this will be your answer. I guess that's an easy question. How about the next example? So how about this? 15x squared y cubed minus 33xy cubed. Okay, so what we're going to do is, again, let's find a common factor. But in order for us to answer this correctly, so let's use the long method. So that would be getting the factors of 15 x squared y cubed, and that would be 33xy cubed. Okay, so that will be the factor of 15. So that would be 3 multiplied by 5, again x squared y cubed. How about 33xy cubed? That would be 3 times 11 times x times y cubed. So again, we are looking for the greatest integer that divides 15 and 33. So that would be what? Okay, GCF is, that would be 3 for the greatest integer. How about for the variables? So you have the smallest exponent. So in this case, you have x squared and x. The smallest exponent is x. Then both of the factor of both monomials is y cubed, so therefore no need to write down. Okay, so or simply just write it down as y cubed. So let's factor out. So this will become 3xy cubed. So that would be 5. Okay, x minus 11. Okay, so this would be your final answer. So let's check if our answer is completely correct. Okay, so using distributive property, let's try to multiply again. Okay, so let's do tick. Okay, so 3xy cubed multiplied by 5x, that would be 15 x squared y cubed minus 33 xy cubed. So we arrive at the same given. So the answer is correct. Now for your own exercise, so you have to try this. Oops. You have to try this one, and we're going to process it later. Okay, so try this. So factor completely, that given is 12a squared b to the fourth minus 16a cubed b squared plus 20a to the fifth b cubed. So you have as many times as you want, as long as you arrive with the same answer. So good luck.